Hello friends, grab your coffee, grab your cookie, but please do not grind the coffee beans anywhere near your cookie, because today we are talking about coffee dust and tea dust. Yes, the dust that smells amazing, travels everywhere, sticks to every machine, and behaves like a combustible organic powder that OSHA and NFPA definitely care about. My name is Michael Klepik, and for 15 years I have been designing dust collection systems for coffee roasting plants, tea processors, instant coffee production, packaging lines, and flavor manufacturing. Let me explain what makes these aromatic dusts surprisingly hazardous. What coffee dust and tea dust really are. Technical description. Coffee and tea dusts are generated during grinding, roasting, crushing, blending, and packaging of dried leaves, beans, and extracts. Technically, first, particle sizes typically range from 1 micron to 300 microns. Second, the most airborne fraction is from 2 to 30 microns. Third, bulk density ranges from 200 to 400 kilograms per cubic meter, depending on roast level or leaf dryness. Fourth, dust concentrations during grinding can reach from 1,000 to 10,000 milligrams per cubic meter. Fifth, both dusts are fully combustible organic materials. Coffee and tea dust look harmless but behave like fast-burning food dust. Where these dusts appear in industry, coffee and tea dust appear in many operations. First, coffee bean grinding and pulverizing. Second, instant coffee spray drying and agglomeration. Third, tea leaf crushing, tearing, curling, and sifting. Fourth, bulk conveying systems for roasted or dried product. Fifth, packaging and filling equipment for capsules, sticks, cans, and bags. Sixth, flavor blending and premix operations. Anywhere coffee or tea is moved mechanically, dust appears. Why coffee and tea dust are dangerous. These dusts create multiple hazards. First, both are combustible and capable of forming explosive clouds. Second, fine particles can ignite from static discharge or hot machine surfaces. Third, dust layers as thin as 1/16 of an inch pose explosion risk. Fourth, coffee oils make dust sticky, reducing filter life. Fifth, tea tannins cause irritation to eyes and lungs. Sixth, dust buildup contaminates products and equipment. Coffee smells great, but coffee dust can blow up a facility. Physical behavior in airflow. From an engineering standpoint, coffee and tea dust behave like classic organic dust. First, they are lightweight and remain airborne for long periods. Second, they generate static electricity during grinding. Third, coffee oils cause dust to stick to ductwork. Fourth, tea fibers form fluffy clumps that clog filters. Fifth, fine fractions behave like smoke and require high-efficiency filters. To keep dust moving, I designed duct velocities from 4,000 to 5,000 feet per minute. Filtration equipment that works best for fine coffee dust. I often use a Cartridge collector. First, it captures very fine airborne particles efficiently. Second, it handles oils in roasted coffee when using membrane-coated media. Third, it maintains strong pulse cleaning. For tea fiber dust, a Baghouse blizzard is ideal. First, it handles long fibrous particles from tea leaves. Second, it tolerates high dust loading. Third, it maintains airflow even with fluffy tea dust. For instant coffee or powdered extracts, both systems can work depending on dust fineness. OSHA and NFPA compliance coffee and tea dust fall under OSHA combustible dust guidelines and must comply with, first, OSHA's General Duty Clause. Second, OSHA guidelines on dust hazard recognition. Third, dust hazard analysis requirements. NFPA standards apply directly. First, NFPA 652, Fundamentals of Combustible Dust. Second, NFPA 61, Agricultural and Food Processing Dust. Third, NFPA 654, Prevention of Fire and Dust Explosions from Particulate Solids. These standards dictate ventilation design, explosion venting, and housekeeping requirements. Proper explosion protection. For coffee and tea dust systems, I always include, first, explosion vents sized for the collector. Second, duct isolation valves to prevent propagation. Third, anti-static media to reduce ignition sources. Fourth, grounding and bonding throughout the system. Fifth, optional spark detection when grinding coffee beans. Organic dust must be treated with serious protection. Capture hood design for coffee and tea. Processing effective capture is critical. First, enclosed hoods on grinders and milling stations. Second, capture points at sieves, screens, and classifiers. Third, enclosed transfer points on conveyors. Fourth, dust pickup at capsule or tea bag filling lines. Fifth, integrated dust control hoods at bulk bag dumping. Good hood design reduces airborne aromatic dust clouds dramatically. Coffee and tea dust may smell wonderful, but they burn fast, float easily, and can form dangerous combustible clouds during grinding, sifting, or packaging. With proper airflow, high-efficiency filtration, explosion protection, and OSHA and NFPA compliance, we can keep these facilities safe while still enjoying that beautiful aroma. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, coffee belongs in your cup, not floating in your ductwork. See you in the next video.